when you have the wave, that is basically up and down motion of the water. And because of that, when you in a boat or ship, you will get some uplift, up and down lifting. So think about a ship. When you have a large ship, that is basically moving vertically up and down. So that is basically a huge amount of power. And if you can harness that amount of power for your useful energy, so that will be the power, and that is also the renewable energy. So we'll discuss. So this wave energy is also the manifestation of the solar energy. But how? So we should know how this wave is generated. So most of the cases, you know that basically wind is generated based on the differential heating of the Earth's surface, and you get the wind. And when this wind move or strike on the surface of the ocean or any open water bodies, and they transfer some of their energy to the water, create waves. So because of that, when you have the cyclone and any other thunderstorm, in that case you will get more waves because of the high wind. So if you look in a pictorial view, you will understand this how this wave is generated. So you will get the generation of the wind because of the differential earth heating. And when this wind will blows over the surface of the ocean or water bodies, it will generate wave. Okay, and it will propagate. And ultimately, it will give some up and down motion. And based on some simple harmonic motion, you will get some energy. So that energy will be utilized for your useful purpose. So are you getting now? So someone is trying to join. No one is responding. So this is the line class. Okay. So now this amount of energy transferred on the size of the resulting this wave depends on the wind speed obviously, and the length of time for which the wind blows, that is the duration, as well as the distance over which wind blows. So these are the factors based on that your wind power, that is wave power or wave energy vary. Okay, and so here we will understand how this wave can be converted into some of the useful purposes in the form of electricity, in the form of compressed air, in the form of other mechanical power. So here you will get some idea about the potential. So basically always when we talk about the energy, you need to assess the potential, or you need to study the feasibility. So because when you will try to harness the power, in that case initially you need to check whether it will be technically economically viable or not. So based on the per unit cost or based on the reliability, so those things are come into the picture. So here that is basically the, if you think measuring the amount of wave power in kilowatt contain each linear meter of wave front. This how this kilowatt per meter will come. We will discuss later. So these are the blue or dark blue locations. You have the highest potential. You have the highest wave, and some of the location here, and some of the location and Australia, that is near the Cape Town, or that is South Africa. So basically, most of the cases, it is basically in this region where you have the more wave. But if you look into for our country, we don't have that much potential in the wave. Okay. but some of the locations they have the 60 meg the kilowatt per meter, which is a huge power. So now talk about the advantages. So when you will talk about the renewable energy, you will get a lot of benefits based on the say, say pollution point of view. Not only that, there is no fuel cost. So so those things are common. But here, if you think about the wave energy as the advantage over the wind and solar, that energy has been naturally more concentrated because of the water. It will strike by the water. When it will create the thrust on a particular board, you have the large amount of power. Okay, so that is energy density or power density is more compared to the wind, and it is free. Obviously, there is no fuel cost or other things. So renewable sources, and these wave power devices do not use large land masses. So this is the separate point. Basically, here most of the things will be in the ocean surface. It will not use any. Hardly it is will get any land mass. Basically, most of the things in the ocean. So these devices are relatively pollution free because they remove the energy from the waves, obviously. An onshore wave energy system can be incorporated into harbor walls and coastal protection. So some of the when you will harness some of the power near the coastal area, so obviously, so there will be some development. So there will be some so as a whole coastal protection as well as the socio-economic development of that area will be improved. If we create the compass the sea space behind the wave energy system. So when you have some power system in the coastal area, obviously it will create some beauty. And long-term operational lifetime of the plant. So basically, these are the simplified or simple devices. So you have a large operational lifetime compared to the other. And obviously non-polluting and enhances to the supply of the energy. So because of the we have the wave in a particular area. So these are the typical advantages we have the wave. But some of the cases it will give you some lot of disadvantages. You should think about the energy, then the thing about the merit as well as demerits. So these are the demerits of this wave energy. So you have the higher capital cost during the installation, high maintenance cost of the systems, and wave energy is intermittent source because you know that wind is also intermittent. Okay, so because of that, so you will not get the power for the 24 hours, and it requires the favorable wave climate. So when you have the wave, in that case you get the power. And another disadvantage is basically investment of power transmission cable to shore. So most of the cases you have the plant in the ocean, so you need to uh, evacuate the power from that, and you need to provide the transmission. So that is obviously cost effective. And degradation of the scenic beauty. So most of the cases people want the so that this ocean should be free of any disturbances free. So it should be open. But when if some of the plants are there, it will give some it will degrade the scenic beauty obviously. And with this plant, so there will be some interference with the some of the coastal factors, navigation, fishing, recreations. So there will be some impact on this. And reduce the wave heights may affect the bees process in the Royal zone. So basically, it will when you have some plants, obviously it will reduce the wave propagation. So that may affect this process. So these are the typical disadvantages. Now here we'll try to understand that is how this power can be estimated with this wave. Right. I have told that wave is nothing but the up and down motion of the water, as well as there will be some movement in a particular direction depending upon the wind flow. So if you consider this as a sinusoidal wave, so if you have a sinusoidal wave like this, and if we give some mathematical relations, so based on some of the factors, say it is the amplitude, this is the wavelength, and this is the period. So this is basically a wave propagation. So if we can provide a mathematical relations of this traveling wave in the form of wavelength, let's say period, and amplitude. So when you have a more amplitude, obviously you get more power. Okay, and that part we can say k, that is a part, and there is basically the velocity, the angular velocity. Or that is sorry, that is called the angular frequency, radian per second. So it is a propagation, and there is a wave number. Now you know that this wave propagation or that will vary with the height, and not only that, you know that on the upper surface you will get the more wave than the lower surface, and it will be zero when it will go to the say base of the that is the ocean. So based on that, and if you can uh, estimate the power, so based on these factors, so what is happening basically here we have that is the wavelength, there is the period. So these are the basically the mathematical relations to estimate the power. And finally, this wavelength can be estimated based on this the period. And there will be some velocity, the linear velocity of the particle that will move in a particular direction. So that can be estimated with this the wavelength by the period, and that is angular frequency as well as the wave number. But how this energy can be estimated based on the energy content of the water. So that will be lifted, and that is nothing but that is a potential energy. So basically, when you have some of the water that will be lifted at a particular height, that is nothing but that is basically the potential energy of the water. So potential energy of water means that is mgh. You have a certain amount of mass, yeah, and that will be lifted at a certain height. So that is mgh. But you need to estimate the certain amount of volume, then multiply it with the density. So then you need to assess the volume. But here, so when you have some uh, propagation, so here the basically the volume will vary with the height, and that is a z. So you need to estimate the total volume, so during the half cycle, and this is basically the lower portion. So total will be the 2z. So that is basically, you know that, so that is a certain volume, and that is basically here that is in the direction of z and in the direction of x. So that is a what we will do. We will do the double integration. That is the x to this direction. That is the half of this propagation wavelength, as well as that is a z to that is 0 to h. That will be, so volume will be estimated based on this, and volume multiplied with the, so that is basically the, and and if you consider the unit width, basically when you are having the volume, in that case you have the three space coordinate. But if you consider that is a per unit width of the wave front, in that case it is only the dx and dz into the rho, that is the basically the mass, and that is basically the height. And if you do the double integration, and in that case you can estimate the total potential energy per second. So that will be the power. Devashish. Okay. So based on that, and if you do the double integration. So based on that, you will get a relation. So that will be estimate the potential energy per unit length as well as per unit width of the waveform. So here, so this is not only the potential energy, along with that it will move in a particular direction. Okay, so you have some of the uh, uh, kinetic energy. So in a, and, and if you consider this an simple harmonic motion, this average kinetic energy and potential energy contribution is equal, considering the harmonic motion. So in a if it is a equal and it will move in a certain velocity, so kinetic energy of also will be the same value. So total energy, so per unit surface area will be the potential energy as well as the kinetic energy. To do the sum of these two, so this will be the relation. So where you will get some idea about the energy that can be estimated. The power carried forward the per unit wave, the width of the wave front. So that will basically the energy multiplied with this. That is the energy, and when you consider in the power, so that will be the watt per meter. So here you have, so this is basically the square of the amplitude, and here this v by u is basically it is called the group velocity of the dip of the waters waves, that the velocity, the who is the energy in the group wave carried forward. So that is the movement. So ultimately, so you have a relation, so that can be estimated, power can be estimated by this relation. So here you have the density, you have the amplitude, you have the power. So based on a particular location, when you can estimate the amplitude as well as the period of the wave, in that case, you can estimate the power potential. So these are the relations, so can be utilized to estimate the power available for a particular site. But when you are thinking about the conversion, obviously that conversion will be less compared to this. And not only that, you have a lot of limitations. You have some the uncertainties are there. So this is basically a relation that we have some idea about the potential. So now, mostly in your course, you should understand so how this wave can be utilized. So basically, you have the wave, so that basically in the so that will lose the energy in the deep water, and in the surface you have the large. So basically, that is the when it will move in the downward direction, so that will lose the friction. So now this wave energy technologies may be at the different locations. It may be near the shoreline, at the shoreline as well as offshore. So most of the cases people can think of this offshore is better than this in the shoreline or near the shoreline. So that is the so, so depending upon the wave. So these are the simple layout will give you some understanding. So this is how wave. Just a second. Sorry, Diana. Sometimes there is some network. Sorry, Diana. Okay. So these are the schematic layout give you some the understanding. Say, so this is basically the ocean surface, and due to this wave and this float or will give you some up and down motion. Simply consider this like a boat, and it will oscillate or it will give some up and down motion. Uh, Even cylinder, so this is basically a cylinder and that is a piston. If this piston is connected with this float, then what will happen? This piston will move up and down, and that is called the reciprocating motion. And you know that how basically in a compressor there is a piston, or in engine cylinder there will be piston. So there is a reciprocating motion means it will create the suction as well as compression. So so this is basically a pipe with a so there is a valve, and when it will create the suction, then what will happen? The it will take the air from the atmosphere to this cylinder. So during the upward motion of the float, and during the downward motion, what will happen? This is basically a non-return valve, okay, or check valve. Okay. So during the downward motion, it will compress the air. Compress the air means so during the compression, pressure within this engine cylinder is more than that of the chamber. So air will move through this valve, and it will stored in this chamber. So when these things will repeatedly done, what will happen? It will this device will be act as a compressor. So air will be compressed by this system. And when you have a compressed air within a certain pressure, that air can be utilized in a different manner. So if you have a uh, air turbine, in that case, so when the high pressure air will move through the turbine, it will generate the mechanical energy, and or you will get the shaft power. And if you connect with the generator, you will get the electricity. And not only that, and not only that, you have a number of application of this compressed air. So you can use this compressed air directly. So this is a simple device that can be utilized for or to compress the air. Similarly, you can lift the water at a certain height of a reservoir. So this is basically the same device, but here it will. So this is like a reciprocating pump. So this is the cylinder, and that is a piston. So when there is suction, it will take the water here, and during the downward motion, it will lift the water to at a certain height. Okay, same thing here also. This basically like a flexible tube. So during the upward motion, it will basically downward motion. You will it will take the water inside it, and during the upward motion, it will compress the air, and that will be so air flow, or you can store the air at a higher pressure. So these are the so device can be utilized for a different way. So are you getting now? So how this wave can be utilized? Wave energy.
Yes, sir.
Okay. So now, if you think this is basically a reservoir at a certain height, now you can utilize this water uh, with a say turbine. You have a penstock. So water turbine can be utilized to harness this water art. So when it will flow through the turbine, it will generate the power. So depending upon your location, so depending upon the potential or site condition, you can think the different techniques. Similarly, if you think about this system like that, so basically this is basically wave front, and if you think this is basically a dark or cam type profile, if you have, then what will happen? So when it will strike on this cam shape dark, then what will happen? It will give you a motion, that is basically a motion with an angle, and if you connect with this thing with some of the piston cylinder or some of the device, so always you will get some motion, up and down motion, and not only that, it will be a movement. So that can be utilized. Similarly here, and if you consider there is a flap pendulum and that is connected with a piston cylinder, then what will happen with when you will strike on this flap, so move, so piston will give you the suction. Okay, so basically suction and compression can be done with this so device, and based on that you can compress the air as well as you can pump the water by this hydraulic pump as well as the reciprocating compressor. So these are the uh, systems may be utilized. Similarly, same thing in a different way, and if you consider this is basically the wave, so that is the lower, and this is basically the upward direction, this is the downward direction. You know, what will happen? So this is always there will be some up and down motion. So here you will get the compression, here you will get the suction. So both the things can be happen using a same device. Okay, so that the basically the up and down motion, and here you will get the suction, here you will get the compression, always with the up and down motion. Similarly, if you consider this is a dolphin type of thing, buoy dolphin, basically what will happen if you have this up and down motion means it will create some of the uh, basically basically it will give up and down, that along with that it will rotate. So that motion will be converted here. So that is basically like a generator. Similarly, these things the same thing but in a single component. So basically here it will basically up and down. And up and down means here you will get the compression, here you will suction. So these are the simple device so can be utilized to lift water, to compress air, or to give some motive power or shaft power to have the electricity. Similarly, so this is the same thing I have told in the that is basically a float, and this is a device. And there is another device there, and that is called the oscillating water column. So how it works basically, a- a- and this and devices are applicable always near the shore. So that is basically the surface. And then what will happen? So when this wave will come here, and it will give an up and down motion. That means, and if you think this is a confined space, then what will happen? So during the upward motion, the air inside this chamber will compress, and it will move in this direction, which is outward direction. And when it will so give the downward direction, basically the downward, in that case it will flow left to right. So it will give through a pipe, you will get some oscillating flow. And if you design a turbine, so that will give you the mechanical or shaft power with this up and down motion of the air within a uh, confined space through a cylindrical pipe. Then, and if your turbine, and if this turbine is connected with the generator, so that can generate the power. So that is basically up and down motion of the water body can create the flow, up and down flow through a passes. So that is basically the oscillating water column. So other device, if you look here, not look here, basically this is a device. So this is a simple platform like thing. So when you have a wave, so when it will come closer, then what will happen? A large portion of this water will come above this platform. Then what will happen due to this so difference in the height, water will flow through these passes. So this is basically the platform, and water will flow through this passage. Then what will happen? And if you have some number of turbines, small turbines are there, then so due to this uh, flow through this section, it, you can generate the power. So this is basically a platform, so that will come uh, uh, repeatedly filled with this water from this wave. that is called the overtopping. Okay, so based on the normal turbine, so that can be utilized like this. So this is basically the platform. So this is also called the pitching device. Mean that is basically here there is a pitching, or sometimes it is called the heaving. So this is the pitching. Basically, what will happen? So when there is up and down motion, that means, so here you will get the compression, here you will get the suction. So always you will get, so compression and expansion is there. So that can be done by this way. Okay. So yeah, okay. Uh, so this is basically, and if you look, so these are the device. In between there will be some hinge, and when this wave will, so basically there is a large. So you look into the size of this. Uh, that that is called a sea snake basically. If you look like that, is a large length, and we have a number of components, and not only the link system. In between there is some distance in arrangement, and not only there is a lot of pneumatic system. Basically, you will get the hydraulic power. So you will utilize this compression and expansion to convert by other means to have the rotating motion, or to have the other type of energy. So think about the length. So these are the large, 121 long. So this is a small power, not that mass, but people can think of that in the remote areas. Sorry. Second. Or some of the cases people can think this type of the device also. So this is basically a reservoir, and that reservoir will be filled by this wave. So when it will, wave will come here, and this reservoir will fill, and that so there will be a difference in the head from this ocean surface to this reservoir, and you can run low head turbine to get the power. So this is basically a scheme to have the power from the wind. So these things already I have told, there is a hose pump. So during the up and down motion, they can create the flow. So basically, when you have required the water flow through a particular location, so that can be utilized in simple ways. So this is the same thing I have told. So this is basically a sea snake. So think about the basically. So there is a huge mass with the complicated device inside. You have number of piston, number of cylinders. So that can be basically give some. So inside this sea snake, you have a number of cylinder. It may be the hinge. You have the some pressure actuator, hydraulic ram. So those are basically the pneumatic devices, or so fluid control devices. So that can be utilized. So this is basically the piston. Based on this reciprocating motion, so your entire system will be utilized in such a way that to have the uh, proper application in the useful power. So already I have the oscillating column. So that is basically the oscillating column. So this is a typical turbine. So that can rotate with this up and down motion of the water within a confined space. So that is basically the turbine. So this is basically the actual schematic of the oscillating column. So these are the different bands at the different location put together, as well as the wave and the okay. So most of the cases you will get some demonstrating unit. So people are not that much confident with this commercial application of this. But anyhow, so this is basically have a use potential. some of the locations. So we can compare with this onshore as well as offshore. Obviously, we get some advantages as well as disadvantages. Advantage means it is easier to access the construction and maintenance, and same thing you will not get that, and less installment cost and grid connecting charges. So these are the common. Though I need to be near the shore and we need to go offshore. So these are common and could be incorporated into harbor walls or the water breaks, providing dual service for the company. So we need to be near it, we will get the dual benefit. So, but lastly, you need to think about the Indian context. Already, I have told that we don't have that much potential in Indian context. So, some of the few installations are available, and we have uh, an institute that is called the National Institute of Ocean Technology, that is located in the IIT Madras. So government of India has given some fund, and so and we are doing some estimation and some doing some more pilot plants of this capacity. So so this is not that much impressive for the Indian context. So these are the environmental impacts we have. Basically, chemical pollution, so less impact on the environment. No problem with the migrating fish. So so because of it is far away from the shore. So this is a brief or some of the idea about the wave power or wave energy can be estimated. It may be utilized for the generation power as well. So if you have any queries, we can discuss. So this is the wave energy. No question. Okay, so here basically you will learn some of the techniques and what is wave energy, advantage, disadvantages. So these are some of the conversion technologies, environmental impacts. Okay, so basically you should understand at least the different type of energy. What is the special features? So you should know. Basically, when you will tell you some of the cases. So this is my opening elective. So when the people will ask some of the question, at least they can speak 45 minutes. So based on a particular topic, it may be the wind, it may be the wave, it may be tidal. So basic information should we have. So that is basically understanding. So next, I'll cover up another. So we have the time, at least 15 minutes. So this is basically the. So so can you you can see the. So can you think about this power requirement to lift this amount of mass within a particular location? Okay, so so this is basically the sea snake. So we have another 15 minutes. Okay, now we will talk about the another. Are you there now? Hello. Okay. So I will try to finish another topic today. So that is the ocean thermal energy conversion. So this is also simply different from the other one. as well as the tidal. So these are all ocean energy basically. So when you will think about the ocean, we have the tidal, we have the wave as well as this OTEC, ocean thermal energy conversion. So what is this? So here there is thermal energy conversion. Basically here we will think about the thermal energy. So that means when you have the ocean, in that case, in the upper surface, the water is basically you will get more heat so directly from the sun. And and if you consider the lower level, say from the it's 100 meter from the surface, so there will be a certain difference in temperature. So that difference may be say 30 degree or 20 degree. So there is a difference between the two layer temperature difference. So that temperature difference can be utilized to run the thermodynamic cycle. Okay, so if you think this OTEC is also the manifestation of the solar energy. So this uneven heating of the layer of the ocean surface that is due to the sun. And top layer of ocean receives the solar heating, bottom layer receives the water from the polar regions. So that will give you a natural temperature gradient. So that gradient is not that much high. But if you think about the amount of water you have with this natural temperature gradient, and that can be utilized to run thermodynamic cycle using some of the different working fluid. So those who are in studied the thermodynamics or the thermodynamic cycle, the Rankine cycle, you can understand better. I think most of the students have studied the thermodynamics as a paper. So that you have the vapor cycle, Rankine cycle, or it, who know about the working principle of a steam power plant. Then what is happening there? In the steam power plant, you have a boiler, and in the boiler, so basically what you will do, you will burn the fuel, that is the coal, oil, and natural gas, and you will generate the heat, a lot of heat, and that heat will be transferred to the water, and this water will be converted into the steam at high pressure and high temperature, and that steam will go to the turbine, and it will work there. Basically, as the turbine means it will strike on the blade of the turbine, and it will rotate at a particular speed, and then you will generate electricity. And when it will flow through the turbine, so there will be drop of pressure, and it will come to the, and not only there will be a condenser will be there, you know that basically it will a certain amount of heat will be rejected there, and then this cycle will goes on. So basically heat will be utilized to have the mechanical motion or the shaft power using the turbine. Same technology we will utilize here, but within a low temperature gradient. In the steam power plant, we have the temperature gradient say more than 500 degrees Celsius. But here it is hardly the 20 degrees. So you need to think about the alternate working fluid, say refrigerant type of thing. So those can be utilized. So here you have the 20-degree difference of the temperature between these heights. That is a 100, sorry, 1000 meter. So 1000 meter the difference you have, and so that maybe the surface will be act as a heat source, and the lower surface will be act as a heat sinks. So that is basically heat rejection will be there, and heat addition will be basically at the source. But here, so this temperature difference is almost steady. So there is no slightly deviation will be there, but mostly steady. So these are basically, if you think about that, so basically hardly we'll get this type of, and that is based on that. If we do the understanding, so think about this plant. So this is a power plant. So what will do? So this is the cold water we'll take from this location. Okay, and basically we will take the hot water from here. Okay, so 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 this is basically you will take the hot water from the So top of the surface, and you will take the cold water from this location. So there is a basically the high. So difference is say 1,000 meter. So here the cold water will come to the condenser, and hot water will go to the evaporator, and based on that, so we will run some of the organic cycle, and that what working fluid will move through the turbine, and it will rotate, or it will uh, help to rotate the turbine, and that turbine will connect with the generator. You will get the electricity. So basic principles is basically we will utilize this cold water as well as hot water to run the thermodynamic cycle or the working organic damping cycle. So, so these things may be operated in a closed cycle manner. How? So basically, you have the cold water. There is a cold water in and cold water out. So that is basically the cold water you will take from the bottom location. Sorry. Okay. So that is basically cold water that will come to the condenser, and the other fluid that is a working fluid. Okay, so most of the cases is ammonia. You know, the ammonia is basically used as a refrigerant. Here, that ammonia will be utilized. So that ammonia will be heated to vaporize with the help of this warm water. Okay, so with this warm water, it will be basically evaporate, and it will pass this ammonia vapor through this turbo generator. So you have the turbine here, you have the generator, and then finally it will go to the condenser. Then it will condense. It will then so the liquid condensate of this ammonia, so that will pump it using a pump, boiler feed pump, and this cycle will run, or it will repeat the cycle. So continually it will do the operation, and you will get the power. So got the idea. So how it will work. Okay. So basically, this is the turbo generator that will run based on this closed cycle. But this system will be the open cycle. So in the open cycle, what will happen? It will work in a single way. So basically, what you have, so you have the basically the hot water, warm water. Then so there will be a flash chamber. So basically, at that flash, the function of the flash chamber is basically it will generate some of the vapor, and that vapor basically a flash chamber, it will reduce the basically the pressure, and based on that it will generate some steam, and that uh, uh, unsaturated vapor, so that will uh, flow through the turbo generator, and then it will go to the condenser. So that will basically you need to create the flow through the turbine, and finally it will go. So this is open cycle, so there is no close. So that is basically the concept here. So there is no requirement of the other working fluid. So this is open cycle. So and this is basically the hybrid. So here we will talk about the both the things, open cycle as well as closed cycle. So this is a closed cycle. So there is a turbo generator, you have the condenser. This is basically the same. And another thing, basically the open. So this is basically the flashing. You're doing some flashing of that, and there is a warm water, and this vapor will come with this. So this is the steam, and that will pass through this, and this is the open cycle, and this is the closed cycle. So combinedly, this is basically the hybrid cycle. So this is the combination of both open cycle as well as closed cycle. So this figure will give you some better understanding of the cycle. So this may be the closed cycle. So this is basically the hot water that is coming to this heat exchanger. So heat will be exchanged between this hot water to this working fluid. Working fluid will convert into the vapor. Then it will move through the turbine, and then you will get the mechanical power, and this turbine is connected with the generator, you will get the electricity. Then this is the condenser, eh, and your working fluid will condensed, and then it will. So this is the closed cycle. Okay, so when you study the things, always try to draw the figure and give you some idea how this closed cycle will operate. So based on this OTEC system. So here basically this is the hot water, this is the cold water. Okay. So this is basically the open cycle. So this is the basically the what I have told, the flash chamber. Okay, this is hot seawater. Basically, when it will flashed into a larger chamber, then what will happen? It will generate the vapor. Okay, the water will pass through the bottom and steam will go up, and this steam will pass through this turbine to have the shaft work and as well as electricity, and this is the condenser. So this is open cycle. So we try to draw the figure and explain how it works in open cycle. So basically, if we look into this systems, basically we have a number of devices: evaporator, heat exchanger, turbine, generator, condenser. So these are the devices are there. So we see evaporator, condenser, cooled pipe, turbines. So most of the cases, if you look into the device, we have the number of heat exchangers. Evaporator, you can the condenser. Those are basically the heat exchangers. Here, heat will be transferred from one fluid to other. But think about the complexity. You will deal with the saline water. You will deal with the so that is material constraint or understanding. You should think not only that it will operate at lower temperature gradient. So these things are there. So these are the common topics. So material basically most of the cases costly. The titanium, so basically aluminum. So you need to think about the material consideration based on the adverse situation. And not only that, here you have the temperature gradient is very low. So you will get a very low speed. Okay, so turbine efficiency or everything will be very very low. So that is why so these are not that much uh, practical implementation of you will get hardly in the world you will get number of plants so those are run based on these techniques. Okay, so but people are trying hard to do the implementation. So these are the locations. If you look some of the locations, you have the higher temperature gradient. So this is a basically specific region. You have a, some of the locations. So this is basically the Japan. That so basically so this is mostly in the volcanic regions. If we have some temperature gradient that is more than the 24 degrees Celsius. So that give you some of the suitable places. So these are the locations you have some larger potential. So this is basically the cycle, thermodynamic cycle. This is the reservoir, and that is basically the source, and this is the sink. Yeah, and you will run this ramping cycle to get the mechanical power. But here you can think. Okay, so these are basically based on the thermodynamic cycle. But problem with this temperature gradient. So when you have a low temperature gradient, you will not get that much of power, as well as you will not get that much of efficiency. And if you consider the Carnot cycle efficiency, so Carnot cycle means that will be the maximum uh, possible thermal efficiency, but you will not get that. So here, this is the basically the low temperature, this is the higher temperature. So here it is less, you will not get that much uh, efficiency. But what are the environmental aspects? So basically here you don't have so that much negative impact. You have some negative impacts, fish eggs, industrial sterilization of land, personal plants, fruiting plants. So these are the environmental impact if we can things, and not only that there will be a mixing of wa- the hot and cold water, but ne- as a whole, this impact is less compared to the other plants. And some of the commercial benefits if you have, and if you consider in remote areas, and if you can utilize some of the power in the form of to running the or to generate electricity or to run the air conditioning device and some other purposes, that may be a different. Not only the some of the cases people can uh, take the ammonia, so basically so help to produce fuel cells. So basically when you have a particular location, you have some minerals, so that may be utilized in that way. So depending upon the site, you can think for the implementation. But as I will finally come to the Indian context, we don't have that much potential, I have told, but there is ocean. That is basically the we have a that is a R&D lab at the IIT Madras, so they are doing some of the research under the guidance of supervision of the Saga University in Japan. So, and some of the plants are planning, so not in that mass, but cities are not in a good position till date. So this is the so these are the some of the demonstrating plants, part of, but not in that way. So problem with the technology and problem with the mature technology and benefits of the ecology. So so these are not that this uh, practical feasibility is not that much good for the tech for the Indian context. So these may be a solar power plants if you consider like that. So not only this, so this is basically the power plant C. So basically you have the solar as well as the wood tech and as a complete package. So and that so this location may be a thing about some sightseeing. So you need to integrate all the things to have a better practical feasibility of the plants. So that may be possible like that. So this is like a plant shape. If you have a number of components, you have boiler, starter generator, condensers. But it is really difficult to build these type of plants and run within a profitable manner. So, so that people will try to do the business. So that is not the charity sort of things. So this is their real pictures. So this is the basically the animation. If they can understand, this is the flow of the cold water. This is the flow of the hot water, and in between there is a basically the generator, turbo generator set is there. Okay, so this is basically the concept of this protect. But think about the when you have a corner efficiency that is maximum, so you are getting the net efficiency is 0.25. So it is hardly 0.25, but if you are talking about the more than 30, 40, 50, so how who will invest? So that is a question. So these are the things that already I have discussed. So these are renewable, obviously. So these are advantages of this: the cost effective, not only that you not get that much of power. So the installation is very difficult. Okay. So this is the only plant. So people have some of the understanding at the Hawaii island. So because of that, they have some of the minerals, not only the power. They are also extracting some of the good minerals out of that. So that is basically the so this is the integrated plant. Not only the power, they are getting some other things or some other benefits. Okay, so this is a brief understanding with the OTEC. So I think you have maybe you get some of the idea about the OTEC, and so this is topic. So any question? So basically, in our syllabus, we have a number of topics, now different topics in different dimensions. So I am giving only the introduction part as well as some understanding. So, okay, and one thing I like to share today, we have a meeting in our basically department BOS. So, so most probably in the 16th March, there will be a faculty council meeting. So there they will decide what will be the mode of examination. So this may be the offline or online. And till date, I don't know anything on that. Okay, so faculty council will decide what to do. So this examination may be the offline as well as online. Okay, so they will decide, and not only that this subject has catered not only the final year, and some of the students they have taken from the third year also. Okay, so so we have to wait from the decision. Okay, understood.
Yes, sir.
Okay, so depending upon that, we'll think so how evaluation of the paper could be done. Okay, thank you.
Thank you, sir.
So I'll share the